Welcome to Physics with Mr. Brazil. Today we're going to be looking at projectile motion, determining the initial velocity. Here's what I mean. We have these problems where we got a horizontal surface or we could have a ramp that can be coming up, but we have something that's going to be shot at an angle and it's going to land at the other side. And I'm going to put an angle of 30 degrees for this problem. And we want to find the initial velocity. Well, we also need to know where it lands, or we have a lot of unknowns. So let's say this particular object lands at 14.9 meters away. So this whole distance is 14.9 meters. Well, we now have a lot of information to solve this problem. It's going to be a substitution problem. Here's what I mean. First of all, we know the initial y is equal to 0 because it's starting at the surface. It is also going to land back on the surface, so that's 0. We know that delta x, the change in the x direction, is going to be 14.9 meters. And we have theta. And we also have g. G is negative 9.80 meters per second squared. Well, we also know, and this is important, all three vectors, I mean the components that make up V naught, Vx naught and Vy naught share one thing in common. They share time. And we can solve for time. Here's what I mean. Let's take the x component because that's a distance. So delta x equals Vx naught times t. Well, t is going to be equal to delta x over Vx naught. Wait a minute, check this out. That's equal to delta x over V naught cosine theta. We now have the ability to do a substitution. Here's what I mean. Since we know the final distance in the y direction is 0, and the initial start is 0, plus, see, we're using our kinematic equation, Vy naught t plus 1/2 gt squared, we have an equation that can be substituted. We know that this is 0, that Vy naught is V naught sine theta times t plus 1/2 gt squared. Well, now we can substitute t with delta x V naught cosine theta. Let's do that. So 0 V naught sine theta bracket delta x over V naught cosine theta. Sweet. These two go away. Now plus 1/2 g bracket delta x over V naught cosine theta squared. Let's see. Let's fix this up a little bit. We're going to have delta x tan theta, sine over cosine, tan theta, plus g delta x squared over 2V naught squared cosine theta, and this is all getting squared. I'm going to put it in parentheses. Okay, so let's take the delta x tan theta, put it to the other side, because we're going to try to get that V naught initial all by itself. So here we go. Negative delta x tan theta equals g del x squared over 2V naught squared cosine theta squared. Well, do a little rearrangement. I'm gonna bring this up so I have some room. So V naught squared is going to be equal to gx delta x squared times 2. I'm going to put the negative out there in front of the 2. And we're going to have delta x. We're going to have, I'm going to take the, let's leave it for now so that you can see this. Tan theta times cosine theta squared. Okay. I'm going to do some removals here. This is going to go away. And that's going to be 1. I'm going to change the tan theta. I'm going to bring it back to cosine. So we're going to have a delta x all by itself on top. Negative 2. I'm going to put sine theta over cosine theta. That's going to be times cosine theta squared. And that one of the cosines disappears, and there's a 1 here. Bring this up again. And now we have V naught is equal to G delta X over 2 sine theta cosine theta square root. Well, let's plug in our values and see what number we're going to get. We're going to have negative 9.80 meters per second squared times the 14.9 meters from above, negative 2. That's good news. The negatives are going to drop. Sine 30 degrees times cosine 30 degrees. Well, it was 30.0. Square it, and we're going to end up with 12.98 meters per second, essentially 13 meters per second. So that is our initial velocity. So these type of problems will require that you do a substitution. You'll see a lot of them. Sometimes they're going to ask you to find theta. Sometimes they will ask you to find some other value, possibly even G, because if it's a different planet. So I'm going to bring this down so that you can see it. But remember, you're doing a substitution. You're going to take the x values or the x components. You're going to put them together and solve for t because all three vectors share t. Okay, and then you're going to substitute it in. Okay, you're going to substitute it in to the equation, and you're going to just have to do the algebra. Other than that, keep practicing your physics, kinematics, and let's get ready for forces, our next unit. Bye.